Hello everyone, and welcome back to another video on trigonometry. So in this chapter we are going to focus on right triangle trigonometry. So um, let's get started. So when we talk about right triangle trigonometry, we're talking about everything that's built around a right triangle. So we've already seen the unit circle if you've watched my other videos. And we talked about this value theta here. And we could name the 6 trig functions based around what's going on with this Cartesian point, right? It has an x coordinate and it has a y coordinate. And since we're talking about the circle, we could talk about the distance from here to here, which is the radius. So this distance from here to here is x, and then from here to here is y. So I'm just going to pull that triangle out to the side here. So right triangle, here's theta, this is x, this is y, and this is r. So before, when we looked at that unit circle approach, we said that the sine of theta is equal to y over r, cosine of theta is equal to x over r, and tangent of theta is equal to y over x. Well, we can take those same ideas and we can think about things in terms of a right triangle. And with a right triangle, we have theta here, same right triangle. This guy is the hypotenuse. From theta, this would be the opposite side. And then from theta, this would be called the adjacent side. So we could think about everything in terms of opposite, hypotenuse, and adjacent. Sine was y over r. Well, in that case, it would be the opposite over the hypotenuse, which is where this is coming from. Cosine, based on this angle, we said would be x over r, which would be the adjacent divided by the hypotenuse. And then tangent, we said was y over x, which is the opposite side divided by the adjacent side. So we can build those trig functions off a unit circle where we talk about things in terms of x's, y's, and the radius r of the circle, or we could think about it in terms of the right triangle where we talk about sides opposite, hypotenuse, and adjacent. And what's nice about that right triangle approach is we could think about this theta value, or we could think about what's going on with this theta value, and everything stays the same. For a right triangle, let's say our theta is here. This is my right angle. Then this side is still the hypotenuse, but this would be the side opposite of the angle, and this side here would be the adjacent side. Adjacent means that it's touching that angle. And then we could find the values for the six trig functions as well. Sine is still opposite over hypotenuse, which would be this side divided by the hypotenuse. Cosine would be adjacent divided by hypotenuse, and tangent would be opposite over adjacent. So you can look at any triangle in any way and you'd be able to figure everything out. Now, if we're missing a side of a triangle, maybe when we have two sides given up to us, we can use that Pythagorean theorem. A squared plus b squared is equal to c squared to figure out any kind of missing sides. Now, an easy way to remember right triangle trig is SOHCAHTOA. You may have heard this back in a high school class. SOHCAHTOA just is a quick way to remember that sine, which is your S, is opposite divided by hypotenuse. Cosine is adjacent divided by hypotenuse. The A means adjacent, H means hypotenuse. And T, tangent, is opposite divided by adjacent, near O and A. So let's look at a few examples. If we're looking at number 11, they're asking us to find the exact value of the 6 trig functions for this theta value here. So this is our angle. Now we're missing the hypotenuse side. We do have to figure out what that's going to be. So we can use a squared plus b squared is equal to c squared. In this case, we're looking for the hypotenuse. So one leg is going to be 2, the other leg is going to be 3. That's going to be equal to c squared. So we have 4 plus 9 is equal to c squared. So square root of 13 is going to be equal to c. And we want to find the value for all 6 trig functions. So sine is going to be opposite over hypotenuse. So it's going to be 2 over the square root of 13. And if we rationalize, multiply the top and bottom by square root of 13, we get that. Cosine is adjacent divided by hypotenuse. So we have 3 over square root of 13, which is going to be 3 square root 13 over 13. And then tangent is opposite over adjacent. So we're going to have 2 over 3. And now that we know those, we can find the other 3. So we can find cosecant. Remember, cosecant is going to be 1 over sine. So it's going to be square root of 13 over 2. All I did was flip this guy. Secant is 1 over cosine. So if I flip that one, flip that fraction here, I get square root of 13 over 3. And cotangent is 1 over tangent, which is going to give us a 3 over 2. So let's look at another example down here. Okay, let's look at 41. They're giving us a picture of what our triangle is going to look like, and they give us some information, and they're asking us to find some missing information here. So they're telling us A is going to be 2, and C is going to be 5. And they're asking us to find side B, angle A, and angle B. So to find side B, we can use the Pythagorean theorem. We know A squared plus B squared is equal to C squared, and we know A is 2, and we know C is 5. So B squared is going to be equal to 25 minus 4, which is 21. So B is going to be the square root of 21. So now let's figure out, how do we find angle A? Okay, that's this angle. Well, we could use sine to figure that out. We know sine of A is going to be equal to opposite divided by hypotenuse. So to figure out what A is, we can take the inverse sine of 2 over 5. And we could go to Desmos. We could fill that in. So we want arcsine of 2 over 5. Remember, you have to use arcsine to figure that out. We need to make sure that we are in degree mode, because we want this in degrees for this chapter. So our degrees is 23.6. And to figure out B, we could take 180, we could subtract 90, which is this guy, and then we could subtract the 23.6. We know a triangle is a total of 180 degrees. So 180 minus 90 minus 23.6 is going to give us 66.4. So there's our missing angle there. So the next thing we need to talk about is the complementary angle theorem. When we have cofunctions of complementary angles, they're going to be equal. So for instance, sine and cosine are cofunctions of each other. The sine of 30 degrees is going to be the same thing as the cosine of 60 degrees. So just go into a unit circle. Here's 30 degrees. The sine is the y value. And if we look at the cosine of 60, you can see that those are going to be equal to each other. So sine and cosine are going to be cofunctions of each other. Same thing with tangent and cotangent. They're going to be cofunctions of each other, and secant and cosecant are going to be cofunctions of each other. So as long as those add up to 90 degrees, then these guys are going to be equal. So let's look at some examples. Number 20, we've got tangent of 12 degrees minus cotangent of 78 degrees, and we're trying to figure out what that is. So what we know is that cotangent and tangent are cofunctions. So that means that the cotangent of 78 is the same thing as the tangent of 90 minus 78, which is 12. And then I have tangent of 12 minus the tangent of 12, and that's going to be equal to 0. So we can use cofunctions to help us figure that out. So we could do the same kind of thing on 21. We've got cosine of 10 over sine of 10, so we know that cosine and sine are cofunctions of each other. So cosine of 10 is the same thing as the sine of 80, because 80 plus 10 adds up to 90. And that's going to be over sine of 80, and that's going to be equal to 1. And then let's do one more. Let's look at 24. We have 1 plus tangent squared of 5 degrees minus the cosecant squared of 85 degrees. So if you think back to all those Pythagorean identities, we had sine squared plus cosine squared is equal to 1. And if we divided everything by cosine squared, we're going to get tangent squared plus 1 is equal to secant squared. And there's our substitution we're going to make. So this is going to be equal to the secant squared of theta, but theta is 5 degrees, so let me write that in. Because remember, this guy works for any theta value, minus cosecant squared of 85 degrees. And we know secant and cosecant are cofunctions, so the secant squared of 5 degrees is the same thing as the cosecant squared of 85 degrees, because 85 plus 5 adds up to 90. And we're going to get 0 for this guy.